Good morning, everyone. We'll start our session. Today's topic it is from the module 5. In that, system testing. We have seen integration testing in the last class. The last part of your fifth module is system testing. In the system testing, what do you mean by system testing? Where it will be standing in the hierarchy in your V model of the testing scenario, where the system testing will be appearing during your execution of the code, that is implementation part. You will be going to deal with unit testing. One step above that, that is during your design phase, what you'll be doing is you'll be just going to deal with integration testing. Above that, it comes system testing. What do you mean by system testing? And above your system testing, you'll be having the acceptance testing. And in both system testing as well as acceptance testing, if you want to go through it, then you need to have the regression testing. We'll just see one by one. See the hierarchy. I'll just try to write those hierarchies. Unit testing. Above this, integration testing. Above this, we have system testing. Acceptance testing. So okay. So on the other side, your specification, from the specification you will be having the design to next implementation. Last part is testing. So with respect to testing, this is how it will be just going through it. So this is the V model that we have just seen it. Some of the times what they are doing is your system testing and acceptance testing will come into a single particular category itself. That means they will not categorize under different stages. Instead of it, they'll merge this acceptance and system testing. We'll just see one by one how it will be validated and what is the system testing is all about, what it is, and acceptance testing, how it will be done, and regression testing, what it will be done. So we'll just see one by one. First, we'll just take a look into this particular table. This table describes you your system testing, acceptance testing, and regression testing. Between that, what is the difference? What you are testing for? Actually, in system testing, we are testing for the completion of the whole particular product, correctness as well as completion. That is a major rule that we are just doing it with respect to your system testing. Whereas acceptance testing, is it useful for the end user? In what way it is useful? Whether they will be satisfied with the product, whatever we have delivered, all those particular details will be collected in the acceptance testing. The last one is regression testing. Any accidental changes, that is, today it may be working fine. Tomorrow, if I test it once again, whether it gives the same result or different one, some accidental changes, whether it has happened or not. That is what we are checking with respect to your regression testing. What do you? Who will be testing this? System testing. Who is getting involved in it? Normally, your system testing and your regression testing will be done by the development test group. There is a separate group for the testing technique. So test and analysis, QA analysis will say it, quality analysis group. So with respect to that test group itself, some people will be there who will be developing the test cases with respect to whatever the specifications that has been given. So that will be done by a separate development test group. Whereas acceptance testing, it will be done in combination with the test group along with some users. The beta version, you can say it. So with respect to that particular beta version, how it will be giving you the answer, depending on that, you can just go with it, right? So ultimately, the user should be satisfied with the product that the that is available in the market that you have designed for, right? So normally with respect to your verification and validation, if you are concentrating, your system testing will be coming under the verification part. Are we going to build a right product? That's what it is. Okay, with respect to the specifications, we are testing it. The same thing happens with respect to your regression testing also. It will be coming under verification only. Whereas with respect to your acceptance, acceptance will be done. Have we built the right product? That means we have built the product, whether it is satisfied, whether it is meeting the user requirements and all those things, you'll be just giving an idea, right? So that is nothing but your validation part. So acceptance testing will come under your validation. System testing and regression testing will be coming under verification. Have we built the right product or are we going to build the right product? Depending on that, you'll be just discussing these two particular parts, right? These two are very important artifacts in your software, in entire software engineering journey. Whichever the software that you just develop, it will be coming under any one of the categories. Have we built the right product or are we going to build the right product? That's what they are saying here. So verification will be done based on that. Validation will be done based on that. So normally keep one thing in your head, verification before developing the product, before doing it. So with respect to our specifications, we are just judging how it will be giving you the output. The output will be judged based on that. After getting the output, if you are checking whether it has meet the requirement or not, that is validation part. Understanding it? So that's all with respect to that. Next, we'll go with the one by one. We'll take it and we'll just try to explore it. System testing. What is a system testing? The name itself suggests that system. That means whole. The whole particular specification, whatever you have given, whatever you have delivered, that is what it will be just taking care. Understanding it? So that is nothing but your system testing. Okay. With respect to your system testing main key characteristics, what are all the things? The whole system or the whole specification you'll be just taking care. And the second one is based on the specification of observable behavior. Verification will be done against the requirements that has been specified and not validation, and no other options also available. That means whatever the specifications that you have given, whatever the requirements that you have just stated, depending on that, your entire system will be tested. That will be verified based on that. No validation. I'm not going to test the end particular product, how it will be done. Before that, whatever the things that has happened, how it will be behaving, whether I can achieve the same particular requirement, whatever I'm aiming for, that is what we'll be just checking for. And it will be an independent design and implementation. Design and implementation does not come into picture here because it's based on your specification. That's what we'll just try to remind the V model that we have just seen it with respect to your software testing part. Okay, so I'll just give requirements or specification part. Below this, what happens is it will be nothing but your design and implementation. Design part or a sketch of your particular thing. The last part is implementation. The next part will be your testing. Once it comes with respect to your testing, during your implementation, what happens is we'll just go through the unit testing. After implementing each code, we'll do this. Right? So above this, during the design phase, what we'll be just doing is we'll just go with the integration, testing. During our requirements and specification part, we'll just go through the system testing. After designing, after going through the system testing, the next part is acceptance testing. You can just say system or acceptance testing. Both will be done here. This is how the V model will be available. If you just want to connect these particular things, I'll just use the arrow mark to connect these so that it will be easy for you to understand. First, from the requirement, you will be designing it. From the designing, you will be start implementing it. After implementation, you will be throwing it to testing. In the testing, once again, the reverse process. In during the implementation part, you will be going through the unit testing. After unit testing, it will be just sending the data to integration. From the integration, it will be just falling in the system and acceptance. So this is how the V model is all about. This is in the V structure, so that's why it's called as V model. So based on this, we are just seeing it. See here, design and implementation does not come in your system testing at all. So based on your specifications only, you will be there just doing this system and acceptance testing. So better you can just say that the key characteristic in the system testing is it is independent of your design and implementation. Design and implementation, rest of the next two steps, it is based on that. So that's why you can just you can easily say that it is done during with respect to the requirements or the specifications that has been fed at the starting point of your scenario. Okay. So the next one is independence in the sense what? Avoiding repeating software design errors in system test design. So during your design, you may end up saying that or you may get some faults or errors during your entire software design, so that can be avoided. That is what we are just seeing it based on the pure requirements only. We are just going it, we're not going with the next particular step, understanding it. So that is nothing but your independence is all about. Next one, independent V and V. What is V and V now? See, first V is nothing but your verification. Second V is nothing but your validation. But second V is ruled out according to your systems testing strategy itself. Why? Because we are not validating anything, we are only verifying it, right? So one strategy for maximizing the independence is system and acceptance test performed by a different organization. That means you should not do that particular system test. System test should be done by some external fellows. That is who does not belong to the your project group or who will be not knowing anything about your particular product that you are designing. But based on your requirements, they need to design it and they need to just verify it how it functions well, understanding it. So then you can say that yes, it has been tested. Okay, that's what we were just making a statement during our quality process analysis, quality process during our quality process when we overtook that topic. So during that particular time, we have just noted one thing. So it need to be given to the external agency for quality check. Why? The reason is for this. It should be an independent one. That means nobody should involve who has written the particular code. Always he will be giving you the right input itself. Who don't know anything, who is an end user. If you think about that particular person who is the end user, depending on that, if you start testing it, then it will be a different scenario. So that's what will be just uh, getting it with respect to your ISO certification or any other particular certification you are just doing it. It is an what I can say, it is independent of any organization, whether it is from the Microsoft, you're designing a product, or whether you're designing a product based on your from the company called as TCS, Infosys, whatever it may be. Very um, what I can say, very recognized company, whatever you say it, based on the company name, they will not give you the certification. Based on the test cases that has been passed, they will be giving you the certification. That's what it will be done. So that is what we need to just know it with respect to your independence, with respect to your verification part. So it should be verified completely by a third party so that no influence will be involved in passing your entire product or getting the particular product into the market. So that will be done. Sometimes outsourced to another company or agency, that will be done. So that's all with respect to it. Outsourcing or for independent judgment, not to save money, but not to save money, but in order to get a better quality product, you need to do it. Okay, so not all outsourced testing is verified and validated. So you cannot say that whatever the system or whatever the company that they have assured you, saying that this product is so and so and it will be giving you the right output. You cannot say that only one particular company, if it gives you the uh, green signal, you cannot launch it, because you may get some problem in rest of the particular company due to other particular test cases what they will be conducting. So you need to have a bunch of such particular outsourcing people, and with respect to that what the output will be coming, based on that you need to get an conclusion saying that yes, your first particular company whatever it has been verified, it has been given that 85% accuracy is given. Next person, particular person, 80%. Next particular company, it will be giving you the accuracy as 87. On an average, it will be 85. So that's all. That's how it will be working with respect to the any developed organization. You cannot say that whatever you have outsourced for one thing, everything works fine. You need to compare with respect to whatever the things that has been or what it has been reported during your own particular company internal testing also. During the internal testing how it behaves, and we need to compare it with respect to the outsourced one. So both the particular things will give you the right particular thing to choose the product. Independence without changing the stack. What is this independence? You are saying that previously whatever you said independent is based on the verification that should be done by outsourced person, then only you will be getting the right product. That's what we have said. But without changing staff, you need to do it means what? If the development organization controls system testing, perfect independence may be unattainable. And but we can reduce undue influence. What do you mean by this? If you don't have a control on the testing team, if the development team does not have a control on the testing team, then always you may say that to the extent your product will be a reliable product or verified one. But you cannot say almost every particular details you have checked it, because you are the one who is going to develop that particular product, and in the same particular group only you are going to build a separate testing phase. But one thing is, if you just independent these two particular parties, then you'll not have an independent influence on that particular party. But what happens here is, you may end up saying that few of the test cases, whatever you have in your mind, whatever your company will be thinking, based on that you may work. But rest of it, if it comes out of the box, any error, you may not be able to handle it. For that reason, give it to the other company. So that's all we just wanted to know about it. Develop system test cases early. So instead of delaying, once the product is finished, after that, if you want to check it, before your particular design phase itself, if you have the test cases ready with you during your requirement phase itself, then it will give you the right product. That's what the meaning of this particular statement. As a part of requirement specification, before major design decisions have been made, you need to test first. And the conventional V model are both examples for designing test cases before designing the implementation. What is the thing that we need to just go through it here? It is based on the specification. It is based on the input that you are choosing it. So it is nothing but you are performing the unit testing itself. It's a black box testing. That is with so not the unit testing. Instead of it, black box testing. That is what you are doing it. Black box testing is done with respect to the input that you are giving it for the system. What happens inside it, we are least bothered. What are all the changes that you are just doing it, we are least bothered. Only thing is based on the requirement, what is the input, what is the output, that we are checking it. That is nothing but your any functional testing technique you can apply for your system testing technique to get through. Understanding it. So this should be done before your design phase. That is what the thing that they are saying it. So structure system for critical system testing early in the project. Say for example, whether with respect to any designing for your any designing the software or the hardware part for your health issues, that is medical related concepts. If you are just doing it at that particular point of time, with respect to the input, what is the expected output? If you just can take care about it, then it is easy for you to design as well as implement the process. After implementing, if you are saying that okay, something has been missed, then everything should be changed, right? So that is what the problem that we are having it here. Critical system is based on your usage that the user wants it to behave. Understand it? So that is nothing but your one of the important concept with respect to your independence related to your changing of the stack or without changing the stack. The next part is incremental system testing. This is incremental system testing. System tests are often used to measure the progress. It is related to your progression. Progression means you need to improve always. You cannot decline in your particular test case. If you have designed a test case saying that, okay, you have designed for 100 test cases, out of the 100 test cases, for the first time that you are performing the testing technique at that particular point of time, either you can use boundary value analysis, equivalence class partitioning, or anything. Based on the input, you just decide which one you want to go with it. Decision table approach also, you can have it. Any functional testing approach, you can just go through it. So during your requirement phase itself, so always whichever the testing technique that you say it, so it should be giving you the progression in the technique. A small progression may also be accepted. Say for example, at the first time 85% of your test cases has been passed. Next time it should be at least 85.11 or 85.01 or something like that. So it should always see in the progression of that particular technique. Next time, one more product if you design once, then it should be near to the accuracy, whatever you have got it with respect to the previous one. So that's how it will be just need to develop it. System test suites covers all features and scenarios of the user. If it gives more test cases has been passed months, then it is understood that all the particular scenarios, whatever is that, everything. That means 85% of the scenario has been passed. It is the meaning is very simple to say in whichever the environment, in whichever the thing that you are just having it, whatever the scenario that you are having it, everywhere you can use this particular you use this particular system to the extent. As project progresses, the system passes more and more test suites. It should be in that particular manner. Assumes a threaded incremental build plan, features exposed at top level as they are developed. What do you mean by this? Whatever the product that you are developing, for one particular specification, one particular output, you are saying it. Next time, one more. Next time, one more. Like that, you may have n number of such particular cases. It depends on your technique which we are using it. If you are going with normal boundary value analysis, if with respect to the input variables that you are having it, with based on that, you'll be developing the test case suite, right? So whichever the test case suite that you develop it, it should be giving you the some incremental output should be happening over there. That means the result should be incremented. The progression should be happening. So that for that you will be building a plan. With respect to that particular plan, how it behaves, for each one of the input with respect to the corresponding output, you will be just designing a test plan. So where it covers all the particular levels of the system, whichever you want to address it. So in that particular manner, it will be just done. Each one of the particular input which will be combined with the other particular inputs that you are having it will be having a one particular threaded application that should be separately taken care. So like that, n number of threads you will be having it based on your test case. So that is what they are just having it with respect to. Each one should give a progress. That means 85% if you are getting it for the first time, next time it should be incremented to 85.01 or 85.001 like that. So it should be done with respect to that. It need to improve it. Instead of 85, 86 also you may get it if you just combine those two. Next time you may get it as 90. So like that, it should be having an improvement. It should not decline anywhere. That is what it means with respect to your incremental system testing. Next, some of the global properties when you just assume with respect to your system testing. What are all those? We are all knowing about this. There is nothing like there are different global properties. The main important global properties that we need to assume or we will be checking is the performance and the latency and the reliability. What do you mean by performance? What we are doing we are developing a product, right? Based on the requirements, we are developing a product. Based on the requirements, we are developing a test suite also. Whatever the test suite that you develop it, whatever the input that you give it, with respect to that, manually if you calculate whatever the expected output that you are getting it, the same output is coming with respect to whatever the design as well as implementation that you have done with respect to the software product that you have designed it, then we say it is performing well. And one more thing, I'll just once again I'll remind you, there is no product called as 100% valid product. So always you may get an error, not for today, maybe tomorrow or day after tomorrow, or maybe 1 hour after also you may get it, or maybe you have not checked with respect to one particular scenario itself, you may get an error. But for today, we may say that its performance is so and so. Performance is based on how it will be behaving with respect to the design that you have made it, as well as the implementation that you have just developed, used for developing a product. After developing it, what is the output? Before developing it, what you have assumed, what you have done it with respect to your manual testing, both will be combined. Based on that, you will be just saying that the performance of that system. And with respect to different environments also, we'll check it. Depending on that, we'll just give you the output. The next one is latency. Latency is nothing but the delay. How fast your test case will be functioning. Is it 1 millisecond within that particular time your first input, first test case has been passed? Is it taking more time? More time, if it is taking, means there is some problem in the entire system. Sir, what is the fixed time that you are having? It need to be rigorously tested. Then only we can say that what is the time. Based on the average time, we'll just say that this is the average time within this particular time interval. If your design is not, or if it is not able to give you the answer, we'll just say that some particular runtime error has been happened. That is, you may get some errors with respect to that. So that's why it cannot be performed well. So that is the latency. Latency is nothing but the delay. We'll just say it. Minimum delay, performance is high. Maximum delay, performance is low. That's all. Reliability based on the performance, we'll say that. That means whichever the environment that you just give the input, whatever the input space that you are having it, whichever the area that you are just going to deal with it, everywhere it should be resulting you or giving you the same particular type of output. It should not be changing. So that is nothing but your reliable one. So everywhere you need to get the same particular type of output. Whatever you are expected it, your system should also behave in the same particular fashion. That's nothing but your reliability is all about. Early and incremental testing is still necessary, but provide only estimates. See, this is what during our particular first phase, that is requirements and specification, we are doing the system testing, right? So with respect to that system testing, if you are doing it early means what happens is you may say that this is what the expectation that we are having, expected output, that is. If you want to get the actual output, then you need to design the complete code. After that, writing the code, once the input is fed for that particular software, what is the output that you are getting it? Depending on that, you will be just getting the actual output of it. Till that time, it will be an expected one. That means early and incremental testing, whatever you are doing it, yes, you can do it. You need to do it. Yes, fine. But you will never get the exact answer of it. You'll be just getting an estimation for that particular scenario. So that is what you can just aim at with respect to your system testing. The major focus of the system testing is the only opportunity to verify global properties against actual system specifications. Whatever the system specification or system requirements is that, based on that, all these global properties will be tested, will be verified. If you get the latency as low and performance as high and reliability is also high, then we'll say that entire system is working fine. How much reliable it can be? Maybe 80%, 90%. But with respect to all those particular test cases, if you are getting that particular amount of passing case, then we'll say that yes, it is a reliable one and performance is also high at all. High end will be there. Next one is especially to find the unanticipated effects. Example, an unexpected performance bottleneck. Sometimes what happens is, okay, you may say that this is what the expected output that you are having it. But if your system behaves in a different manner, then it is unanticipated effect. That is, we are not checked for that particular, or we have not taken care of that specification at all during our design as well as implementation, which will be a very important concept to just check your performance of the entire system. That is, unexpected performance bottleneck will come into picture. Bottleneck is nothing in the sense, without that you cannot move further. Or that is a major part that you need to just address it, but you have failed to address it during your design and implementation part. So that will be done with respect to this. So that's also we can just try to expose or try to explore those type of effects. Understand? Next one is Context dependent properties. Context dependent. Independent is okay. We have done it with respect to that. Independent in the sense nobody should get involved in those persons who will be developing the product. They should not get involved in testing, designing the test suite also. That's the first step, right? So that is with yeah, without changing your staff. With changing your staff, some external agency will come into picture and they'll just do it. Now, what is this context dependent properties is all about? See, based on your particular system development, what it says is, yeah, after the completing this slide, we'll just stop. Okay, so this will be the last slide for today. Context development dependent properties. What is this context dependent properties is all about? Beyond your system global properties, whatever you are saying it, some of the properties depend on the system context and use also. Maybe your environment, maybe your configuration with respect to the environment, or how the system will be behaving in that particular environment, in which particular temperature it will be behaving properly. All these are dependent properties, like this, nothing but your context dependent properties is all about. And one more thing with respect to your privacy, that is nothing but your security issues, depends on both system and how it is used. For example, medical records system must protect against unauthorized use. See, with respect to your medical records, it should not be made available to all the particular patients that they are visiting. So, with respect to doctor only should access it. That too, with respect to the doctor who is the patient that they are visiting, or the patients who will be visiting to that doctor. Only that doctor should see those particular patient records, not all. It should be maintained in a confidential manner. Suppose one person will be ready to donate the kidney. The entire particular details of that person should be confidentially maintained in the hospital. It should not be produced to any of the patients. Maybe the patient who needs it, or maybe the patient who wants it, anything. So you should not disclose it. So that should be maintained. So that is based on your context dependent properties is all about. Security depends on the threat profiles. That is, any threat that is with respect to your passive or active attack, whichever the attacks that you are just getting it, depending on that, your security reasons will be your security, or the encryption and decryption technique should be maintained. That is what it is. So testing is just one of part of the approach. That's it. Nothing else. This is what you call as context dependent properties. This is with respect to system testing. With this, I'll stop here. Thank you very much for your patience listening. We'll just continue the rest of the class tomorrow. Okay.